Not all circuits are as simple as being a series circuit or a parallel circuit. A lot of our circuits are combinations of the two. So it's really important to be able to identify, is it in series or is it in parallel? So again, the mantra, be the current. Do you have a choice of directions? If you have a choice of directions, then you're in parallel. So if you get to a point in the circuit where you can go one way or the other, anytime you have a branch, you're in parallel. Do you have to go through more than one resistor? So at some point in the resistor, it could be part of a branch. Okay, these two, the current in that branch has to go through both of those resistors. So those two are in series. So you want to ask yourself, do I have a choice of directions because I'm the current, or do I have to go through both of these resistors? And that'll tell you if it's in parallel or if it's in series. So here's an example of a combination circuit. We can look at it and go, ah, yuck! But we don't have to because it's not that hard. It's really, really, really not that hard. So let's look at this. If I'm the current, I leave the positive terminal of the battery. Okay? So I'm leaving the positive terminal. I'm flowing along and I get to this spot right here. So now I'm the current and I get to this spot right here. I have a choice of which way to go. So these two resistors here are in parallel. Okay, so we can find the equivalent resistance of that part. Let's continue real quick. Then the current comes back together at this point, and when it gets here, it has another choice, and it could go to the left or it could go to the right. So we have two parallel circuits here. So what we need to do is we're going to take this and we're going to squish those parallel circuits down so that they are one circuit. Now, how do we find the equivalent resistance when we're in parallel? Do you remember from the last one? Think about it. Pause. Go look it up. Okay, you looked it up. So the way you find it is 1 over Req equals 1 over R1 plus 1 over R2. Okay? So 1 over our equivalent resistance, so we're going to do the top part. This is for the top part. Is equal to 1 over 100 plus 1 over 250. So when we do that, we get 1 over Req equals 0.014. Because remember, we're solving for 1 over Req. You use the x to the minus 1 button, so this was, another way to do this was 100 to the minus 1 plus 250 to the minus 1. So we get 1 over Req is 140, or 0.014. So Req, if we take 1 over that, our equivalent resistance is 71.4 ohms. So that's for the top part. So we'll remember that, 71.4. And then for the bottom part, why don't you pause the video, see if you can solve it yourself, and see how it works out. So how does your work look? Did you get 127.3? Actually, it's 127.27272727. Good? Okay, so here's what we did. We took 1 over the 350, because we have 350 there, plus 1 over 200, because we have 200 there. And so we added those together. 350 x to the minus 1, 200 x to the minus 1. So that's 0.00786. And then once we got that, we hit x to the minus 1, and we get 127.3 ohms. Now, don't be lazy. A lot of us are tempted to be lazy. We're going to now redraw our circuit, and where those guys were, we're going to replace them with the resistances that we found. So here's our circuit, and we found that this guy was 71.4, and this guy here was 127.3 ohms. Okay, so now if I'm the current, I have to go through both of those guys. I don't have a choice. So how are those two attached if it has to go through both of them? Those two are in series. So when we find the equivalent resistance for that part, that's the easy one. That's just add them together. R1 plus R2, 71.4 plus 127.3, which is really close to 200. 198.7. So what that means is this whole big circuit here, the big circuit that we started with, behaves as if it was one, boy, I'm messing that up, aren't I? Behaves as if it was one circuit that was only 198 ohms. So the reason we want to do that is because we can use the equivalent resistance to find out how much current's coming from the battery. And we need that before we can go and find all the other currents and voltages, which we will do in a future video. So V equals IR. We have our 24 volts is equal to, we're solving for our current, and we're going to use our equivalent resistance for R, because we're trying to find the current coming from the battery. And this is what the battery sees, is this 198.7 ohms. So 24 divided by 197.8 comes out to 0.12 amps. Okay, and we will use that later, but not today. But that's why we're trying to find these equivalent resistances, is we're trying to get that current from the battery. So let's try one more. So this one's a little bit different. In this one, if I'm the current, remember to be the current, I have to go through those guys. That one. I don't have a choice. I have to go through that one. So that one's in series. But once I get to this spot right here, I have a choice of directions. So these two resistors here are in parallel. So we kind of look for places where they're obviously in series or obviously in parallel. And this one, the first one that we were talking about, isn't in series with another one right next to it. So we kind of skipped out right now. But these two here are obviously in parallel. So we're going to find the equivalent resistance between those two. 1 over 30, 1 over REQ equals 1 over 30 plus 1 over 50. So our equivalent resistance comes out to, notice I'm starting to skip steps here, 30x to the minus 1 plus 50x to the minus 1 is 0.0533, and we go x to the minus 1 to get our answer, 18.75 ohms. Okay, so now we're going to take this and we're going to redraw it. So we know those guys there behave like they're 18.75. So now we have our positive and our negative. We're going to go through our 20 ohm resistor. And we've got the 20 ohm resistor on the bottom. Those guys haven't changed. But this comes from those guys there. So this is the 18.75 ohms that we just found. So we just squished them down and made them 1. And so now if I'm the current, I have to go through that guy. I have to go through that guy. I have to go through that guy. So I don't have a choice to go through any of them. So these 3 resistors are in series. So we're going to add them together. 20 plus 18.75 plus another 20 is 58.75 ohms. So this big whole resistor, this big one up here, is behaving like it's a 58.75 ohm resistor. So let's redraw that real quick. So we have the one battery, the positive terminal, the negative terminal, and this is all behaving like it's an 18.75 ohm resistor, and we had a 10 volt battery. So let's find the current coming from the battery. V equals IR. 10 is equal to I times 18.75. So 10 divided by 18.75 is 0.533 amps. 0.533 amps. So that's how much current we have leaving that battery. And just kind of as an aside to get you started on the next one, since we have 0.533 amps leaving the battery, guess what? That has to go through that resistor. So that's also the current through that resistor. And then when the current gets up here, it's going to split. And so some of it's going to go this way and some of it's going to go this way. But the total of those two is going to be this 0.533 amps. And then it's going to come back. They're going to come back together right here. And so that 0.533 amps has to go through that guy back on his way to the negative terminal of the battery. So we know the current through this one, and we know the current through this one. And we can find the current through those two. But we're going to talk more about that in the next video, because enough's enough. All right, I'll see you later. Bye-bye.